Hi everyone, my name is Niels Voskens. I'm a technical artist at Breda University of Applied Sciences, and today I'm going to be covering a video on how to procedurally generate LED volume meshes for ICVFX using Houdini and Unreal Engine. Okay, so let's get started. This is going to be a tutorial on how to create a procedural LED volume mesh generator for in-camera VFX inside of Unreal Engine, and we're going to be using Houdini to create the procedural tool that will allow us to generate these meshes that will have the proper projection once we import them into Unreal Engine. Here you can already see a bit of the variations that we're going to be generating and testing out the tool. So yeah, let's dive into Houdini. Okay. So before we open up Houdini, I want to show you what the requirements for this mesh are. So if you want to go into the Unreal documentation, you can look up in-camera VFX quick start, and then you will see a full breakdown on how to create the mesh, what UV sets it needs, but I summarized that in this slide. So the mesh itself cannot have, has to be split basically. So each individual mesh cannot contain a larger curve than 90 degrees. Otherwise you're gonna get visual degradation once you hook up the camera and start projecting the perspective onto it. So just to keep that in mind, that's why we're gonna build this setup to be configurable in a way that we can split the mesh to our desired spacing amount. And then the other important part is it needs two specific UV sets. One is a normalized UV set, so per each mesh that we're going to be generating, we're going to need the 0 to 1 normalized UV coordinate space. And then the second UV set is going to be the full mesh aspect ratio, basically. And the scale, it doesn't have to be normalized into the 0 to 1, but you can keep the aspect ratio so the actual projection will be even for your texture patterns and stuff like that. But if you want the full breakdown of it, you can go into the Unreal documentation in Camera VFX Quick Start, what I mentioned before, and here you can see everything. So step 1, how to set up the project, what plugins you need into the project. We're also going to be covering that at the end of the video, but just so you know, this is a nice place where you have everything put together, and you also have some examples on how they are making their meshes inside of Maya, and the UV space, and they explain why you need specific UV spaces, and also how to import these meshes, which I'm also going to be covering at the end of the video. So yeah, and their example is basically a LED panel that is like 500 millimeters by 500 millimeters. We're going to be replicating this for our project, but that is also going to be configurable in our procedural tool. So yeah, also one last thing to mention, when you create the Unreal project, it's better off if you just go into the films and video templates and select the end display one, because this is already going to have all those plugins that are shown in the documentation. Those are going to be already enabled in this project, so you don't have to go in manually and do it yourself. And the only thing that we're going to have to do later is just create the end display, hook up the meshes, and then see how our procedural mesh generator works and see it in action inside of Unreal. So yeah, let's just go into Houdini itself. How we're going to be generating this mesh is based on a spline. So the user will be able to draw a profile, and that profile is then going to have the logic that will generate the mesh based on the LED panels and the LED panel amount that you want. So let's dive into it. I'm going to be creating a geonode. I just call this LED volume. Let's go into here. And I'm going to start by doing a circle first. And why I'm going to do this is most of the XR stages or screens are usually like have a dome kind of shape. So that's kind of what we're going to be recreating here. I'm going to just add a bit more resolution. That doesn't matter since we're going to add more resolution later, but it's more to get like the general shape. And then a radius maybe of 5 centimeters or 5 centimeters, 5 meters. And that is quite large, maybe just 3 meters of radius. That's going to be all configurable later, but I want to create an open arc of 180 degrees. And this is nice, but I want it orientated the other way around. So how do we do that? This will be also configurable, but if you want to change like the actual degrees of your curved wall, you can do that here. And to have this already be centered, we're gonna do a simple expression. So we're gonna copy the degrees channel. We're gonna go into the rotate Y, paste it as a relative reference. Can I make this bigger? There we go. And then we're gonna divide it between 2 and add 90 to it, so it's oriented the way that we want to. And what this is doing basically, if I now make it bigger or smaller, you see that it stays centered and aligned. Now with a lapse align, we're gonna put it at the center. So for the Z, we're gonna do the min. So the origin is basically the middle point of the LED, or like the profile itself of the curve. Cool. So that's to get started. Then what we're gonna need is to resample this line. So all of these individual primitive, or the distance between the points, is the actual panel size. Let me just save this before I do that again. So we're gonna go into the Avenue project, save this as Avenue tutorial LED. Boom. Okay, so now I can save it without that popping up again. And I just add a resample node here. And what this is going to allow us to do is set our desired length of the LED panels. So on the example, they mentioned that it's 500 millimeter by 500 millimeter in their example. So that's here. So we're going to copy this essentially. And that's the value on the resample node itself. But the problem is right now, if we scale these up and down, is that the length is actually not constant throughout the spline. So you can see it's like perfectly trying to fit in the amount of points. So to disable that, we're going to do even last segment, same length. We're going to disable this. And now you're going to see a difference. So that edge is now going to be jumping because it's retaining the same distance for every point or every primitive basically. And this is what we want, since we want the geometry to actually reflect what the hardware of the actual real screen is doing, because we want the exact panels in there, as you see in this example here. Each square or each quad is basically representing a panel. Okay, cool. That will do that for us. And now we're going to tackle, I'm going to put this back to 180 degrees, how we're going to split this mesh into basically the sections that we need to get the proper projection. So it's not more than 90 degrees, right? Let's make this a bit, well, never mind. So we want to split this, and how we want to split it is, first I'm going to show you why we want to, or not why we want to split it, but how we're going to create the mesh. And that's going to be using a sweep line. So if we connect the second input, this is going to be our height profile. So if we make this 5 meters tall for now and have 8 panels in there, so you can see here primitives, we need to sweep the second input. So this is kind of how the tool will work. We're gonna now split the mesh. So this one before we sweep. And why we're going to do that is so we can basically have the different chunks of geometry that we're going to be exporting to Unreal. So if I go in here and do a carve node, for example, this is a way to just cut throughout a spline. So if I put it on 0.5, that's basically half of my spline. And if I keep both sides, now you can check on the primitive number, I have 2 instead of before I just had 1. And if we sweep this now, these are going to be split meshes. So we can check that with an exploit view. Yeah, there you go. So these are now separate meshes. So that's kind of what we need. But the problem is, if I do this with a carve, there's sometimes that our mesh is going to be split in the middle of a, so if I change the radius, we're going to see this, yeah, here. It's splitting up one panel in half. And you see this is not actually what we want. We want to split the mesh evenly. So if it's uneven panel number, then it has to take for this left side the whole thing. So it has to carry out this one on the left, and this one will just be a bit smaller size than this one, but that will keep the actual panels or the hardware itself reflected in the mesh, so you are not splitting panels in half basically. So how are we going to do that? We're going to add a simple line of wrangle, primitive wrangle node, but first we're going to need to convert our line into split primitives. So what's happening with this node, you can see in the primitive number itself. Points per primitive number. This is just one primitive. You can also see that here. One primitive doesn't have any data, but if I now do the example, or like convert to line, sorry, you get 0 to 16 primitives. And we're going to do this now to loop over each point or each primitive through a wrangle. And we're going to add some logic to it so we can split this in half. And then we're going to add a primitive wrangle for that. So I'm going to explain the logic of what we're going to be doing. It's not that difficult, but let's go back to our presentation. So this is what we're going to be doing. We're going to be getting the line itself, which will contain X amount of points and primitives. In this case, we're going to do it on primitives. But let's say our primitives go from 0 to 8 on our line that has X amount of distance. If we divide each primitive number by the max primitive number itself, which be in this case 9, it's not 8, since we also have an index 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9. If we divide each number by the maximum, so we get like a normalized length basically, we're gonna resample or like rescale or give an attribute to each primitive that goes from 0 to 1. And we can multiply that by the value that we actually want to split the mesh in. So let's say we want to split it in 3 chunks. We multiply this value by 3. So now we have our line resampled into a 0 to 3 space, because that's the amount of that we multiplied it here. And if we then do a ceiling, which will basically just put the decimals, it will move them to the closest whole number. So actually going to the bottom, so 0 would stay at 0, 3 would stay at 3, but everything that's in between here would actually go down to 2, because it's the closest whole number going down. And then the same goes for all the points that are in the middle between 2 and 1 will go down to 1. And this is how we are gonna get this effect. Here in this example, you see that there's 4 groups generated at the end, but this is not going to happen since we are dividing this by the total amount of primitive numbers. And this example shows it with 8, but this is actually 9. So if you divide the last primitive index, which is 8, by the total amount of primitives, which is 9, you're never going to get 1. So this is never going to get 1. It's going to be like close to 0.99 something. If you have a really long line, and then this is never going to be 3, it's going to be a bit less. So you're never going to get this last point. It's going to be moved back here. So you're going to have 3 chunks of points. So that's already explanation. Now let's go in here and create this inside of our logic for the wrangle. So I hope this is visible, but we're going to create a new integer, which is going to be our split number. And that's equal to a new channel that we're going to create, which is going to be split number. Let's call it like this. Cool. So we can create already the channel by clicking on this icon. Now our split number is going to be this value here. Then we also want to store the total of the primitives number. So that's going to be 17. Oh, because we have primitives from 0 to 16, but since we have 0, it will be 17 in total. So we want to store that in a variable here. So that's going to be with n primitive number of primitives basically. And we have to choose the input in here. And the input 0 means basically the stream that goes into the first input of our wrangle node. So we already have that. We don't need to store the primitive number itself since it's an attribute that we can already read. So now, same as this node here, the curve u, we're gonna use a 0 to 1 value to split our mesh, or we actually want to normalize our primitive. So we're gonna store that into a new variable that's gonna be a float, since we need it from 0 to 1, which is gonna be our u attribute. And this is going to be our prim number divided by our total. Cool. And let's just make sure this total is a float. So we get that, don't get any wrong averaging. And then we're gonna create a last attribute that's gonna be the actual ID of it. So in here, we're gonna add all the logic. We have our 0 to 1 and we have our channel. So now we basically need to get our 0 to 1. So that's going to be looking like this. We want our u attribute, which is our variable that is our 0 to 1, multiplied by the number of chunks that we want to split it in. We need to floor this, and I'm going to be adding a 1. It's not really needed, and I want to store this then into an attribute that can pass along. So if we do I add and then just call this ID and just set it to our value that we already have above, this should give us already, you can see here, an ID attribute, and they go from 3, 2, and 1 because we have 3 split. If we split numbers 2, it goes from 1 to 2. We can probably visualize this easier by, if I control middle click on the node itself, I can see all its properties, and then if I go in here, I can enable visualize ID, and you can see through the color. Let me just put the background too dark. Yeah, now you can see the difference in color. So we have red for the left side, green on the other side, and then if we want to split our mesh in bigger chunks, that's happening already here. It's not really that visible with the colors, but you can change how you visualize an attribute here. So if I put marker, yeah, you see the numbers here. So 4, 3, 2, 1. Maybe instead of saving it into an integer, let's just do this into a string. So this is going to be string ID or name. I think if we save it in a name, it's better because we want to later split our mesh based on the naming itself, so we can package it and send it to Unreal. So it's going to be wall underscore, and then we're going to add our ID to it. And this needs to be transformed into a string like that. So now we should be able to visualize our names. These are random colors, but if we now do it with labels, yeah, there you go. So every primitive has now its own name, and we can now add some logic based on this splitting. So I'm going to put the split back to 2, and now we could already send it through the sweep, and we would already have our walls 1 and wall 2 group. And if we then check how they're split, and if we do 3 groups, we're going to have 3 meshes. So this is working all fine. Let me just disable this. It's going to be a bit nicer to work with. Now we need to make sure that we're getting the proper UVs for this mesh. And are we getting any in the UVs? If I press Control Space, check the UVs. No, we're not getting any UVs. But we can actually, in our sweep node, go into UVs attributes and compute the UVs. That's pretty handy for us. So if I look at my UVs, they don't look quite right. What we need is a UV space from 0 to 1 based on every split mesh. What is happening right now, because of this convert line here, we have different primitive numbers. So the sweep is going through every primitive itself and sweeping and doing a 0 to 1 for every primitive. So that's why you see all that warping in the UVs. If I go into the UV space, all the primitives are split and then just put into UV coordinates. And this is not what we want. Even if we normalize this, it's not doing much. So that's not going to work. So what we're going to do is loop over every mesh that we want. So based on their name, we're going to loop over them and just combine them back together. So I'm going to do a loop for each named primitive, and the attribute is already name. So if I do a single pass, you're going to see that we're going to loop over that specific one. Now we're going to do a polypath. This basically weld it back together into one primitive. And now if we disable the single pass, we're going to have 3 primitives. If I plug this now into the sweep node, we're going to see some improved UVs. Still not exactly what we want because they're rotated. So I can see now, let's go try to visualize the name attribute as random from attribute. So this is a bit clearer now on how to check. So we have our separate UVs, and they go from A to 1 and A to 1 and A to 1. That is working, but the UVs are rotated. So let's just quickly fix that. We can also just see it in our UV space here. Well, not since it's normalized, but that helps us because if we add a UV transform, essentially what we need to do is just rotate it here 90 degrees like this, and just add 1 to it to put it back in the centrum. So I'm just going to do that manually here, 90 degrees. Oh, and that's going to be a minus 90. My bad. There we go. So they're back in the centrum. If I go check my mesh now, you can see they're properly aligned and facing upwards. So 0 to 1 to P, and then 0, 1 P, 0, 1 P. So this is exactly the UVs that we want for our mesh itself once we import it into Unreal. If I split and make just 2 chunks of this, same logic still is applying. If we make 5, still same logic is applying. And this is perfect because the resolution of the grid is the exact resolution that we want. We're going to assign it later to the actual panel number and panel width and height. But for now, this is quite nice. So now we're going to be working on the second UV set. So for the second UV, let's go back to the slides. We need the same aspect ratio as the mesh aligned. Maybe in the documentation it's a bit better explained. So you can see here, basically that's their UV or like mesh itself. So the same aspect ratio, the same scale is just into the UV space. It even goes beyond the 0 to 1 coordinate space they have. So it doesn't matter where it's placed, if it's inside or outside the boundings, as long as it contains the same aspect ratio. The scale only affects how the tiling of the patterns for your green screen are going to be projected onto it. So let's just do that. And to do this inside of our Houdini tool, we don't need to split the mesh. We just need to do this sweeping again, but from before we split the mesh. So now this is just like one connected piece, and this already should have UVs, but these UVs are not the ones that we want. So now we actually want the proper UVs that are not normalized. So if I go back into their attributes and not normalize this one, I can see this is the aspect ratio. Again, it's flipped. So we're just going to copy paste this one into here, and we have them oriented correctly. So just to check. Yeah. So now here you can see it goes from 0, 1 to P, and then it loops over and over. But this is exactly what we want. So if we look into the coordinates itself, this is the same aspect ratio of the mesh, just in UV space. So this is perfect if you want to project the proper patterns on there. You can see also here, this looks not warped, and it will never be warped. Compared to if we add a lot of chunks, for example, and here you see they start warping, but you kind of need this for every mesh, and this will still keep the nice UV space. Let's put this back to 2. So we need to transfer this back now, and how we're going to do that is just adding a rename node. Since we want 2 UV spaces, this UV attribute is going to be called UV2. So we have a different, once we transfer and it doesn't override it basically. If you want to check now your UV space, you can go into Control 5 to go to the UV space and just check. Oh, wait, I put this into, oh no, that's fine. So yeah, there you go, UV2. And if I go back here, this is UV1. So we're going to just copy the attribute to our main stream of geometry. And we're not going to copy the color. We're going to be copying the UV2. And this one is stored in the vertices. So there we go. Now our mesh has the first UV sets and also the second UV sets. So that's perfect. That's exactly what we want. And I think now what we have over is to just clean up the geometry. So let's do an attribute delete, and we're just going to be storing and keeping our UVs. Position is stored by default, and our name. And we want to delete non-selected. So we're storing the name still, and on the points itself, we don't have anything, but here we have the 2 UV sets. And just for good measure, we're going to triangulate this mesh, because Unreal is already going to do that. But if we triangulate it before, we already know we're going to get this exact mesh like this into Unreal. And the last thing is we're going to package this. And we're going to pack based on the path attribute and name attribute. So here now you can see we have 2 different paths for wall 1 and wall 2. This is going to help for importing into Unreal Engine. And then last step is to actually export this. So we're going to use a RobFBX. Let me just find a nice location for this. And this is going to be LED tutorial mesh.fbx. Cool. We're going to convert the units. This is going to help to transfer the actual size into Unreal. To not get the annoying error, we're going to do compute smoothing groups. And for that, we are also going to need normals on our mesh. So let me just put this in here. So there we go. We have normals. Let's make sure we don't delete the normals. Cool. And we're going to build hierarchy from path attribute. This is just going to package the split meshes into our FBX, and then we can import it properly into Unreal Engine. Okay, cool. And we have something that works. It's not perfect because we cannot really control the amount of panel numbers that we have right now. So we're going to make a small controller. I'm going to add here a null, and then to change its color and size. So if I want to change the shape, I press Z on my keyboard and I get this panel down here. I'm just going to make it round, and if I press C, I can change the color. There we go, make it yellow, and this is going to be our LED or volume settings. If I right click on it, parameters and channels, and add a parameter interface, now I can tweak these values here we don't really need, so we can make them invisible. And I want to be driving this by the same way they're doing it in the documentation. So I want the actual panel size to be driving our generation, or like procedural LED volume generation. So this is going to make it neat. Put a folder in there, and we can do it with a float 2 for the size, I guess. So there's going to be panel size, and we also are going to need an integer, which is going to be panel y amount, so the height itself. Cool. So let's just apply this. They're now set to 0. Maybe we want to add some defaults to that. So we can go here into the channel itself and set this to 0.5 and 0.5 for the default value, and the amount of panels we're just going to make it, I don't know, 8, 7, 8, something that would make sense. Obviously this would then, if you have a real XR stage, you put in your values so you can tweak it from here. But now we want to hook these parameters up to the actual nodes that drive the system. So for easy use, I am going to add a new view here for, not view, but parameters. There we go. And pin it down. So I can now drag it from there. And the first variable that we're going to change is this. So this is going to be our X size of the panels. So we're going to copy this, copy parameter, go into the example, and just paste relative reference. So that's already working. So if we change the size here, and that's driving our generation. And we're going to use the Y panel amount and the size itself to drive the vertical profile. You can see here with this, if I edit my line, I can make it taller and bigger. So I just need to make this distance the amount of panels times the amount, or times the size of the Y axis. So let's just add that. So the length needs to be this Y size base relative, and then we're going to copy the Y and add it here. So we're paste relative. There we go. So if I have less panels now, let's put it to 2 panels. And this is also not right, because we have way more panels in here. We have now 5 panels. So that is driven by the amount of points we have. So we just need to copy our panel amount into the points, base relative, and we need to add 1 to this, because you see we don't have any panels at all now. Yeah. So there we go. And those are now perfectly squared. So if I add more panels, these will keep the actual hardware actual scale. And the only way to control the X length is by changing the input. So right now it's a circle. If I make this 5 meters by 5 meters, then we're just going to have more panels. And if I do the profile instead of a curve, a line now, this should all still work perfectly. So let's just make this line direction on X axis and make it a bit bigger. So here you can see how it's generating our mesh. Oh yeah, and we can also probably expose the splitting variable. So let's just add a new parameter, and that's going to be an integer 2 outside of the folder. It is going to be split, our split variable, and our default is going to be 2. So we can grab copy parameter and just add it to our primitive wrangle node, base relative reference. So now we can drive our generation, our mesh generation, through the controller itself. I can close this. Cool. So I think the last step now is to import this into Unreal and see how that looks in there. So this works. And the cool thing is we can have now different profiles, and just make a funny one. So Bezier curve. Maybe this one is going to be broken, but that's going to be an easy fix. Yeah, you see here it goes up and down. So we kind of need to do an orient along curve in here, so we get the proper values as the up. So the target up vector needs to be the y-axis, and yeah, there you go, fixed. So this is kind of it. Oh, I deleted my circle. Okay. So let's import this into Unreal. So basically we can save to disk now, and this is going to be 3 meshes, 3 split meshes that we can import into Unreal. So let's do that. So I'm going to go into my folder, to Avenue, Unreal, open up the project itself. So let's see how that's gonna look inside of the end display itself. So we also need to set up some stuff to make the projections happen, but we're gonna go over it right now. So while this opens, I'm gonna make our curve with circle, which I think is like the most standard one. So just gonna make this again, just make it 5 meters radius, 180 degrees, and then that same logic that we did before. Copy parameter, base relative reference divided by 2 plus 90, I think it was. And it has to be an open arc, obviously. There we go. Cool. So we can save this to disk. And we already have our project. Okay, cool. If you open the template, you're going to be seeing this. There's already like a default end display config in here, so you can move this around and see how that works. But we want to create our own one. So I'm just going to make a folder. This is going to be avenue volume. And we are going to import our mesh first of all. So we're just going to go import, and I have it saved here. The one that we did today is LED tutorial mesh. Cool. So if we import this, now if we go back to the documentation itself, you can see we need to use full precision UVs. So let's do that. UVs, use full precision UVs. It's already toggled on, but you probably have it by default off. And in this case, we're also gonna untoggle combine static meshes. So this will actually, I'm just gonna show you. We will have our different walls, wall 1, wall 2, and wall 3. So these are exactly what we want. So let's just make an end display and hook it up. So if I right click in the content browser, look for end display config, and we're going to create a new one, end display config avenue. Cool. So let's just open up this. It's going to have a default end display screen. We don't really need this one, so we can delete it. And I can just drag in my meshes. So drag them into the root component. And this is our properly scaled already LED volume, which is massive. And I kind of want to be able to move them all together because now they're all like split. So let's just add a transform and display transform handle, root parent transform to the root, and then the walls go all to the transform itself. So in here you would move these things according to your, if you zero out the panels, I cannot do that in bulk, but let's just do it one by one. Now our origin is in the transform itself, and if you know the distance from your basically XR stage, then you set it up here correctly and accordingly. So let's just do it like this. Cool, nothing's happening still because we need to make a new node and assign the screens. So add new cluster. The resolution I'm just gonna do 180. The resolution is probably not gonna be right, but let's just add into our node here and the viewport. And in the viewport itself, I want to divide the width by 3 since we have 3 panels. So we're going to do that. Oh, this is a default VP node, but I'll just delete that. And this is going to be our first mesh. So if we duplicate, oh, the host is not even the right size. Let's just redo that. And this should be 190 by 180. Cool. There we go. We can delete this one or just keep it and divide this by 3. This is more like it. And then in the projection itself, instead of symbol, we're going to use a mesh, and we're going to select our wall 1, which is our left wall, and then copy paste this over. I'm going to do it 3 times since we have 3 meshes, and then select for the second one wall 2, and for the third one wall 3. Cool. Still we need to assign a camera, but this is already our stage. So if we import it in here, you can see we have our proper end display already set up. Now the only last part is going to add a camera. So this is an ICVFX camera. Cool. And if I point it at the screen, this should already be working. There you go. Let's just add this a bit closer so you can see the thrustum. Boom, it's working. And this is already using the proper UVs that you need for the actual mesh generation. And let's see this in action. I am probably going to make this a bit bigger, and to properly visualize this, I probably want screen viewport screen percentage multiplier. So this, not this one to one, the other one. Yeah. And now you can see the full resolution also in the viewport itself. And if you move this, cool. And basically the camera is still working. Everything is using the proper projection. So if you move the camera, you see how the perspective warps. So that's kind of working. The cool thing is now we can import our panel again like really quickly since we have this tool made. So if we dive back to Houdini and I say, oh, it's actually not a 5 meter, but they said last minute that they changed it to a 3 meter screen, and that we actually have more panels going up, and instead of a curve, it's a line, and it's a flat LED volume. So we can just go back in here, save. So if I go back into my Unreal project, go where to my meshes are, and re-import them. Hope it doesn't crash. Yeah, you have to be a bit careful with importing meshes with the end display inside of the level already, but it's no biggie. But yeah, that kind of the tool in action. Let me just once it's open, yeah, there we go. I'm just gonna delete my end display from the scene. Now let's re-import this and drag in my end display. Yeah, so the projection is still working and everything just works fine. You have to be careful though. Right now I just set up a random resolution of my screen, but this would actually have to be the resolution of your panels and all that kind of stuff. So you would have to change that inside of your node cluster, and here the resolution of the node, and then the proper resolution for each panel. But you can extract that information also pretty easily from your Houdini scene by knowing the aspect ratio of your screen and the pixel density. So yeah, I think that kind of covered everything that I wanted to cover. So I hope you guys have fun creating your own end displays and configurations, and expand the tool or try out different stuff. And yeah, I hope you guys enjoyed it.